Ladies and gentlemen, button pushers and wrench turners, welcome to another episode of Something's Broken. My name is Taylor Goodyear and I own TG CNC Service out of Wisconsin. So this week I had, actually the last 2 weeks, I had a job in DFW area, Texas, uh, and it was a subcontract job that I was asked if I wanted to dive into it, and I was like, hell yeah, I'll dive into it. I'll dive into anything if I think I can fix it. And my buddy out of Chicago got a hold of me, asked me if I wanted to go down to Texas, and yep, sign me up. So I went down 2 weeks ago. I traveled Saturday, stayed in St. Louis. Saturday night, I have family that live there, so it was nice to be able to see them. And then woke up Sunday and drove the rest of the way to Texas, and then at the customer Monday morning. So this machine, I won't talk too much about it. It was kind of a nightmare. Not gonna lie, I did a lot of work to it, and the work that I did not fix the problem. So, and this happens more than people think it does. So I show up Monday morning with the actual contractor there that reached out and jumped through hoops of trying to get a hold of me and my buddy and whatnot. So we meet up Monday morning. We get into the customer. I start checking the machine. I start indicating the lower sub base turret. This is a twin spindle, twin turret turning center. It is a 2000 model. And the lower turret, from what I understand, there's a lot to it, and I don't want to talk about all of it because some of it is kind of throwing shade, and I don't want to do that. But the OEM was in. They had some issues with the load deviation between two ball screws, and the lower x-axis deviation between the master and slave ball screws were deviating so much that they could not get them to run consistently without the motors overheating because the deviation was so much. So basically, one motor was fighting to keep up with the positioning of the other motor, and basically vice versa. I got in there, started indicating ball screw ends. I was indicating parallelism of ball screws, indicating parallelism of the linear guide trucks. I resynced these ball screws probably fucking 10 times, man, in the span of 3 days, because 3 days we spent just trying to check everything and trying to rule out everything that we possibly could. And a little history of it: the maintenance team there, great guys. He just didn't really follow steps because they didn't really have steps to follow. So they didn't properly stretch the ball screws, and there was question about the rebuild before on the ball screw assemblies. So you have a fixed end, which is the motor end of the ball screw, and then you have a support end with the support bearing block. From what I understand, one of them got broke somehow. The master end support bearing block got broke, and they purchased another one, and they did some work to it in house, and yada yada yada. I don't think there was much of a problem with that bearing block. I indicated everything that I possibly could on it. The height of the two bearing blocks to each other was 20 microns. So I mean, 20 microns is less than a thou. It's smaller than a human hair, kind of. Just in the height difference between the two bearing blocks. So I didn't think that was a problem, even though it was a new bearing block. I moved forward with checking parallelism of the linear guide rails, and those were bent at cutting position. I seen a 40 micron bow in the master side, and sometimes on these linear guide rails, depending on how long they are, the longer the better, in my opinion. The short ones are kind of a bitch to try to straighten on the machine. A lot of times, the shorter they are, there's no straightening them. The bend is just there, and you have to replace them outright. Like I said, the longer they are, you get a little bit more flex in them, so you have a little error that you can get and get that out. Sometimes you're not lucky, and sometimes you can't get it, and you have no choice but to replace the guide rails. It happens. I tried to straighten them, and I had no luck. The best I could get was 30 microns on the bow, and this was over a 2-inch stroke, 3-inch stroke, so not very long of a stroke, and you have a bend of almost 2 thousandths in that linear guide rail. I mean, and you can't get it out. It's got to get replaced. So by Wednesday, after we swept everything, checked parallelism of everything on this lower turret axis stroke, finally made the decision, all right, we need to just completely start over, because we have no idea how many hands have been in here. We have no idea what was done, how the ball screw assemblies were built. We don't know. We need to just start completely over. And they had another crash that we didn't know until like basically Wednesday. So once I was told that, I was like, yeah, we just need to restart over. I'm gonna completely disassemble this entire lower base and start completely over. So we moved forward. Everybody was on board. So we moved forward with removing the turret. After removing the turret, removing the sub base, because the sub base is what is attached to the linear guide trucks and the ball screws. So I need to get all of that off in order to properly indicate everything new back in. Now, on this specific OEM machine, they do a pretty good job of having master edges, like ground edges. So when you install new components like linear guide rails, they have push blocks, and it'll push them up against those ground surfaces. So it makes a lot easier installing linear guide rails instead of floating them in or epoxying them in, which fucking sucks. So if you ever run into having to epoxy and float in linear rails, it sucks. That sucks. I would much rather do it on a ground edge than an epoxy edge, and I've done both. So got the linear guide rails swapped first, got the parallelism of these two to each other within 5 microns, so I was pretty happy about that. Moved on to rebuilding the ball screw assemblies, and I walked through with maintenance on the proper way of rebuilding the ball screw assemblies. I don't stretch them until they're on the machine, and I stretch them with no weight on the ball screws. That's just how I was taught. And somebody out there might do it different. If it works, hey, great. This machine specifically called out a stretch of 7 to 12 microns of stretch. I usually tend to go on the higher side of stretching, and people might ask, what is stretching of a ball screw? Some OEMs don't call for a stretch, some do. In this case, this OEM, all their ball screws get stretched, at least from what I understand and what I've worked on. They all get stretched. There is a formula, I guess, of stretching ball screws on these OEMs. It is 25 microns per 1 meter of length of ball screw. These were nowhere near 1 meter, so 7 to 12 microns, even going on the higher side, is quite a bit. They're just really short ball screws. So I you guys have heard me talk about thrust direction of bearings, and on in this case, the fixed end or the motor end has one thrust bearing, and then the opposite end, the support side, which is the gravity side, takes three thrust bearings. So when they did the bearing blocks before, there was a big question on whether or not they had the thrust direction the correct way. And they did. But we didn't know that. I didn't know that going in. This was something that I need to make sure is right. Because when I went to go take those ball screws out, the slave side had no torque, no stretch to it. I mean, the KMT nuts were just basically hand tight. And then the other side, the KMT nuts were so fucking tight that I basically had to knock them more than usual to get them to loosen up because they were so fucking tight. That is not the proper way to do ball screws, especially when you have a master and a slave. They need to be stretched as even as possibly to each other. So rebuilding the support side bearing blocks, we made sure that the thrust direction was the correct way. I checked the print. The print shows you physically the thrust direction of the bearings, so that was helpful. One thing that you might run into in the future as these OEMs start to gatekeep a little bit more of their information, they're not going to show you the complete breakdown of the mechanical assemblies that you're looking at. So you won't be able to see the thrust direction on the prints that come with the machine anymore. And the only way to get that information is if the OEM is willing to give it to you. In this case, I already had some secret documentations that showed me thrust direction, so I didn't need that from the OEM, and I actually gave the customer a copy too. So now they know if they ever move forward in the future of doing their own ball screws again, they know the correct way to do it. They know the stretch, so on and so forth. Moving forward, I indicated both ball screw assemblies. The master side had a little bit of a twist in the bearing block, and I think this is the one that was brand new, and the customer reamed the holes on a mill or something, and that's not the proper way to do that. You actually indicate these bearing blocks in on the machine, and then you ream them on the machine. That reams the capture hole, both capture holes, the casting capture hole to the actual bearing block capture hole. You have to ream these together. So when they reamed them off of the machine, the pins holes were offset, so they were kind of twisted a little bit. Now I did my best to try to twist it back. I got it within 20 microns on the twist, and then I tried to ream the hole as best as possible, but it didn't work the way that I wanted it to. But I was okay with 20 microns of the twist in the bearing block. I was okay with that at the time, only because I would understand seeing 10% deviation in the two ball screws from 20 microns. That is reasonable for me, especially after you crash it as many times as they have. So nothing is ever perfect and won't ever be perfect when you crash it several times, but we can get it functional. At least I thought I could. Moving forward, I indicated parallelism of both of the ball screws to the linear guide truck. So I put an indicator on the linear guide trucks, the master and the slave. So I always start with the master, and then I indicate everything into the master. That's the slave side linear guide rail, and then master ball screw, slave ball screw, all get indicated into the parallelism of the master guide rail. That is your master. Everything comes off of that. Parallelism, height, so on and so forth. So I got the ball screws in within 20 microns, both a parallelism to the master guide rail. So I was pretty happy with that. Um, Even with that Baron Black being a little twisted, I was like, okay, I'm pretty happy with this. Everything looks pretty good. If I was happy to keep everything within a thou of deviation, of parallelism, and height wise to each other, I was happy with a thou. So moving forward, I was only planning on being there for a week, and a week turned into 2 weeks. It happens. I had no work back home. I had some contractor work, and he was able to take care of that while I was out on the road for me. So shout out to my contractor. And so I didn't have customers screaming for me back home. Eventually, I did get customers screaming for me back home, so I had to come back home. I kind of ran out of time at that customer in Texas. So moving forward, we started reassembling the machine. I put the sub base on. The sub base has set screws on the side of the casting that you use to push up against the precision ground edge of the linear guide trucks. And it's on the slave side, which I don't like. Like I said before, everything comes off of the master. So I would have felt a lot better if those push bolts or those push set screws were on the master side and not the slave side. But since we indicated within 5 microns of the parallelism between the two guide rails, more than likely there would have been no twist in the sub base putting it back on. So I got the sub base on. I got those set screws torqued down. Got that sub base parallel with the axis stroke within 20 microns. There's no precision ground edge on the sub base, at least on the surface. So it was kind of hard to indicate it in, but you see 20 microns of parallelism or something like that. I'm okay to roll with that. So moving on from that, we got the turret on. Now, one of the things that I want to talk about of this fucking sub base is underneath all of the connections for the turret, hydraulic hoses, electrical, all come through the center of the sub base. The sub base has a Y-axis on it. Everything comes through the center, and it is a motherfucker, dude. To get this shit, we had to suspend the sub base over the guide trucks, and then I had to reach underneath this heavy ass sub base with my arms with barely any gap and try to get 4 bolts in this cage, basically the support cage that held the cat track underneath the sub base. And this thing was a motherfucker to try to get. It sucked. I hated it. But taking it off was considerably more worse than actually putting it back on. Putting it back on wasn't too bad. Taking it off fucking sucked. So I was able to get that the cage bolted back up underneath the casting, so the cat track comes up through the center of the sub base, and then you pull it through, and then you set the sub base down once you get that. It sucks. They don't give you any room on those machines to reach your hands under and whatnot. And I'm kind of a big boy, so it's not much room, and it just sucked. Chewed my arms all up, but whatever. I ain't no bitch. So moving on from there, we got the turret back on. The maintenance guys did great. I kind of had them do some of the work just because I wanted them to kind of learn as I was there, and they kind of asked me to kind of teach them as I was there, which I'm all for. I have no problem teaching anybody if they ask. I'm all for it. So we got the turret back on. We got all the connections hooked back up, and we get the machine on, and I resync the ball screws at the fixed end. First, I should say this. I like to tighten ball nuts at the closest range, or the as close as you can get to the fixed end of the ball screw. So the motor end, the motor bearing support end, get that as close as possible, and then tighten your ball nuts there. That's how I was always taught to do it. Don't try to tighten your ball nuts in the middle of the stroke of the ball screw, because you have sag. That's inevitable. Even when you stretch, you're still going to have a little bit of sag in the ball screw. So I was always taught to, when you tighten them in the middle, or wherever you end up ending with the shutting down the machine and doing the ball screws, when you turn it back on, tighten your ball nuts, and then run them to the fixed end, loosen them, and then re-torque them to the torque spec of the bolt. That's a pretty good, safe way of doing it. So I did that, resynced the ball screws. I had to find the x-axis 0 point of the machine, which is they have an installation diagram that shows you that. If you guys know what OEM I'm talking about, they have that in their installation diagram. In this case, it's 185 millimeters times 2 divided by 25.4, and that would give you your inch, which I think was it 15.5669, I think. So that's the 0 point. Now the 0 point is a boring bar holder swept to the main spindle, and from there you zero your relative, and then you move the distance that is calculated as your 0 point, and then that's your 0 point from cutting position, or center of a boring bar holder, to the center line of the main spindle. Everything on these machines, these types of machine, they all come off of the main spindle. Your main spindle is your datum point, basically. That's your master edge in this case. So move down from there, and I resync the ball screws, and I start running it, and what do you know? Didn't fix the problem. We still have a 30% to 40% deviation in load between the two ball screws at cutting position. And talk about a sense of failure. I hate failing. It sucks. But I explained to the customer that we had to start over. We had to. Because we had no idea where the ball screw assemblies were. Parallelism to the linear guide rails. I obviously seen the bend in the linear guide rails. That didn't help. There was just too many factors to not start over. We had to start over and know that everything was done right and everything was parallel to each other as close as possible. And it unfortunately was not the fix. So I tried shimming both bearing blocks up. I thought maybe the heights were maybe just a little different, but they weren't. They were still within 20 microns. The support and bearing blocks both have ground liners underneath them for cases like this. Sometimes you have to shim them, or sometimes you have to grind them. In this case, I tried to shim them up, because if I shimmed up and it didn't help, then I didn't think going down would help either. And it's easier to add than it is to subtract, because once you subtract and you subtract too much, you're fucked. So I always like to add first, and then if I find out that adding doesn't work, then we'll look into subtracting. And when I say that, I'm talking about the thickness of the ground liner, the precision ground liner, would in any application that it's being used in. So started talking to the customer about it. At this time, I'm kind of running out of time. I have customers screaming at me back home. I've been there for 2 weeks. I could keep digging into it, but mechanically, I just felt like I'd done everything to kind of rule out that it wasn't mechanically. At least everything that I checked, I could not find anything wrong mechanically. Talking to the customer and then talking to the contractor, one of the motors ended up being replaced. And I was kind of. Usually you don't have to do this, and that's retune motors to drives. But there's a rare case where when you have crashes, surges happen in drives or internal power modules, IPMs. Uh, from what I've been kind of explained, I've never really dug into drive IPMs. It's just not something that I do out in the field. It's not really something you can do out in the field. Maybe you can, but I just never got into that extent of drive units. But sometimes whatever happens inside of drives from crashes, you'll get surges that are sent through the drive, and the drive will almost be stuck in that state. So in this case, there is a slight possibility, that it is the drive unit that is causing the deviation in the load between the two. I don't have any way to prove that. Usually, for service, like myself out in the field, the best way to do that, which sucks, is just start swapping parts. That's kind of how you eliminate when nothing is slapping you in the face and telling you, okay, hey, it's this. You need to do this. Sometimes it's not that easy as much as we want it to be. And when it becomes like that, and I've talked about this before, I hate being just 50% right on something, because there's still 50% chance that it's not right, and I don't like that. I want to be at least 95% sure that it's something before I, like, yeah, we're going to spend $5,000 on a new drive unit. I don't like doing that. I hate doing that. So there's a slight possibility that it is the drive unit. And I just don't have the time to swap it. I don't have a drive unit in my truck or anything like that. So I told the customer it might be a good idea to reach out to the OEM of the drives, have them come in, check the tuning on the motors. Like I said, very slight chance that it's the tuning, but need to start eliminating everything that we possibly can, because mechanically I didn't find anything wrong. So they understood. Obviously they weren't the happiest. It's understandable. Hey, I just spent all this time and I didn't fix the machine. But we're kind of in the process of elimination now. And when it gets to that, it fucking sucks, because I call them career killers. And my buddy in Chicago knows exactly what I'm talking about. When you do so much on a machine and you just keep doing stuff and nothing is fixing the machine, I call that a career killer, because it kind of makes you look like you don't know what the fuck you're doing. But it happens. It happens more than anybody knows, that you can get into situations on machines and you think it's this, and you replaced the component, or you doing an adjustment and it's not that, and then you have to start a process of elimination, and it happens. It sucks. It becomes expensive, but sometimes it's what you have to do. And when the OEM comes in, they kind of do the same thing. They do a process of elimination when they don't have a definitive answer. It happens. I will sit here and admit it 100 times over. Sometimes I have to go through process of elimination, and it sucks. It sucks. And when you run out of time and you don't have time, and you kind of leave the job site and it's still broken, I myself personally count it as a failure in my eyes, and I fucking hate it. I hate it. I hate having to walk away from the machine that I can't fix, or I run out of time or something like that, because I don't make excuses. I hate excuses, and it'll eat at me for a while, for sure. Um, it's gonna fucking eat at me, but it is what it is. You know, I have to keep moving forward. I have to move on to the next job and become focused. Otherwise, you'll domino effect and you'll be stuck in the career killer mode, and you won't get out of it. So that was Texas. I love Texas. I got a couple of buddies down there that I love hanging out with down there. One guy always takes me hog hunting, which is fun. I don't know if anybody's ever done it, but it's a fucking blast. My buddy down in Houston, who is a Mazak technician, he's awesome, man. I've been friends with that guy for years. I have a buddy in DFW, the one that takes me hog hunting. I met him at a customer when I worked for my old OEM, and we've been friends ever since. I love his both guys have great families, but you know, when you're traveling for work or something like that, and you meet people like that on the road, I mean, it's great, man. And they stay in contact with you, and you know, they always welcome you over when they know that you're coming down. It's great. It's that's one of the plus sides to traveling for work, is just meeting the people across the country and then staying in contact with them, and then they end up being great friends, lifelong friends, you know. Yeah, it's not always the ones that live in your city or your state. It's ones that live miles and miles away. You know, and you can pick up the phone and call them or meet up with them, and it's like you guys never missed a beat. You know, and you could spend years away and not see each other or talk to each other, and then it's like, hey, I'm coming down, and it's like nothing changed. We're still friends. I love people like that, man. It's great. Um, so next week, there is a potential job Monday. I was gonna hop on the sales wagon and start knocking on doors again, because I'm a little slow right now. But I had a customer hit me up Monday. I'm gonna go check out a grinding machine and see if I can help them with the issue. I'll talk about that next week. And then my old college that I graduated from hit me up and asked me if I would be willing to fix one of their vertical mills. Yeah, fuck yeah, absolutely. The spindle is out in it, and they got the spindle ordered and whatnot. So we'll be doing that. My contractor and I will go out, and we're gonna do that Wednesday and Thursday. I don't see it going past Thursday. It's just a cartridge style gear spindle, so it shouldn't take long at all. We should probably have that spindle out and the new one in within probably 5-6 hours, and then everything from there is just commissioning. So that'll be next week. I have a week-long job coming up in Virginia with my old OEM. That's in February. I think it's the second week of February, so that'll book that up. Um, and yeah, that's all that's going on right now. Hopefully, work starts to pick up a little bit. I am kind of looking forward to getting back into the sales part, because I haven't advertised Fanic service at all, Fanic robot service at all, and I took a bunch of training last year in Michigan at the Fanic Training Center. So I need to start moving into advertising that and letting everybody know, like, hey, I offer that service, the repair service now. So I need to start getting into that, and I am pretty sure that I am going to hire a part-time sales contractor. I think that's the logical way to go moving forward with growing my company. Just because I just don't really have the time. But now I do, now that I'm a little slow. So that consideration is going to be coming up more and more here within the next couple of weeks, and start reaching out to people and see if anybody's interested. And I'm going to make it really easy for it. It's not going to be anything crazy, but I'll talk about it like next week or the week after, about what, how I'm doing that, and how I'm going to hire the person, and how I'm going to, structure the job on my end. Motivational time. So I don't really have a motivational quote right now. But what I want to talk about is sleep. And I don't think a lot of people really understand how important sleep is. I know some people will sit there and like talk about, okay, if you want to be so successful, then you only need to sleep 5 hours a night, yada yada yada. Okay, that's fine. If that's how you are, that's how you are. But there is so much research on how important recovery of your body is with sleep and the correlation. Sleep is basically your repair mode of your body, mentally, physically, hormones. This is where your body repairs from the absolute shit beaten out of it that you did the day before. Sleep, in my eyes, I've become a lot more focused on my sleep, and I've seen a lot of big changes because before I sucked at sleeping. I couldn't stay in a REM sleep longer than 3 hours, and I was up constantly. And there's a lot of steps that you can take to improve your sleep. I won't get into any of that. Just watch some YouTube videos and do some research. There's a lot of advice out there on how to improve your sleep. But I I hit the gym quite a bit, like 6 days a week, and I go pretty hard. So the recovery process is based in the sleeping portion. And if you're having like some mental or physical issues, the first thing that I would say is how's your sleep? Get your sleep better. Get at least 6 to 7 hours of true REM sleep. And I won't go into REM sleep, just research it. It's yeah, I'm not going to go into it, but get your sleep figured out. Stop thinking 4 hours of sleep is going to be good for you, because there's so much research that proves that it's not. And ever since I changed my sleeping and improved my sleeping, everything has just gotten better for me. My recovery, my mental state for sure has definitely improved. But that could be numerous factors, gym, stuff like that, vitamins. But if you're struggling physically and mentally and just not recovering, or you're still sore the next day, or in 2 or 3 days you're still sore in that same muscle group you worked out, work on your sleep and then move on to nutrition, supplementation, and go from there. That's just my advice. That's just from what I've experienced over the last couple of months of figuring it all out. And it's kind of, you're exploring. You don't really know. I feel like a lot of people don't know their bodies. They don't pay attention to their bodies. They don't know what their bodies need. They don't know what their bodies don't need. And they just don't listen to it or focus on it. They just live a normal life or think that it's normal. And sometimes it's just changing your diet will completely change the way that you live life and the way that you feel physically and mentally. And sleep is massive with that. Massive. So I hope me talking about it might kind of spark some ideas for some of you. Just try to improve your sleep. And I think you might see it improve a lot of aspects of your life. So, well, thank you. Excuse me. Again, for checking out Something's Broken. My name's Tayler Goodyear, and I own TG CNC Service out of Wisconsin. We'll see you guys.